Hello students, in this video we will deal with some more methods of separation. That is, we will study about chromatography, distillation, fractional distillation and how can we obtain different gases from air. So first we will start with chromatography. Is the dye in black is a single color? You all must have seen ink. You know how you can separate ink from water. That was through evaporation. But now we have to separate the different components of the ink. Ink is never a single color. It is a mixture of color. And these mixtures can also be separated through the technique of chromatography. It was first discovered by M. Tiswell, a Russian botanist. Okay, and it was first used for separation of colored substances from plants, and therefore term chromatography was given here. Here you can see the ink is a mixture of different colors, and by using this chromatography we can separate all the components of ink. Water here is a mobile phase and stationary phase is the chromatography paper or the filter paper that is fixed, and we are using water because it will be rising up, it will be traveling, therefore it is a mobile phase, and paper is a stationary phase. So chromatography is a Greek word from chroma, that means color, and graphy means to write. Okay, the basic principle used here is that substances are soluble in same solvent, but their solubilities may be different. Okay, when the substance that is more soluble in the solvent, it moves faster and gets separated from the other substance which moves slowly. So let's see this through the diagram. This is the spot of ink, this is water in a beaker, and the paper is held by a pin on a piece of wood. So when water is here, it will start to rise up in the paper. You can see this ink has splitted into its components, and you can see here as the water is rising up, the color which is more soluble, whose solubility is maximum, will travel to a highest level, and the color which has a lesser solubility will be at the lower level. So this is chromatography. Different uses or applications are to separate colors and to separate drugs from the blood also. This technique is used. Let's see the next thing, how we can separate mixture of two miscible liquids. Immiscible liquids you are able to separate by differential extraction, but miscible liquids, it can be separated by distillation. Here what happens is that the liquids have difference in their boiling points. The more volatile liquids, that is having lower boiling points, distills out first, whereas the less volatile component distills out afterwards. You can see here in the picture, it is having a mixture of acetone and water, and you all know that boiling point of acetone is 56 degrees Celsius only. So as the heat will be provided to it, acetone will start to convert into vapor state. And here is the condenser. The vapor, they will pass through this condenser, and after passing through the condenser, they will convert into liquid state, and it can be separated in a different beaker. What thing will left out here? It will be water, because water will change into vapor state only at a temperature of 100 degrees Celsius. So you can use distillation, but it is for two liquids. Okay, what will happen if you have more than two liquids? How you can separate? It can be done by fractional distillation. It is a process of separating two or more miscible liquids by distillation and collection of fractions boiling at different temperatures. Okay, so in the diagram, there is an additional thing which was not there in distillation is your fractionating column. Fractionating column is just a tube which is packed with glass beads. These beads provide surface for vapors to cool and condense rapidly. So what will happen here? Difference in the boiling point is the reason for fractionating column to be used. As the liquid will rise, they will form a different layer in the fractionating column and then they will be condensed and it can be separated. You have studied this fractional distillation in case of petroleum also in class 8. So the liquid is heated and they are collected as per their boiling points. The different applications of fractional distillation are, they are used to separate mixture of miscible liquids like alcohol and water, benzene, toluene, etc. For separation of crude oil from petroleum into different fractions. It was there like kerosene, petrol, and it is also used to separate different components of air. So let's see how we can separate the components of air. This is the setup. Okay, so first the air is filtered out, filtering the impurities out of the air. Then what happens? The next step is air is compressed here to a pressure of about 200 atmosphere. So when the pressure is applied, air expands and becomes hotter. The hot air is transferred to the freezing unit and here it is cooled up to minus 200 degrees Celsius. Then it is passed through a separator. Here what happens in the separator? Carbon dioxide, it gets solidifies at dry ice at a temperature of minus 78 degrees Celsius and carbon dioxide gets separated from here. Now air is free from carbon dioxide. Then it is passed through expansion jet. Here the gases are liquefied except neon and helium. Remember this thing. And then it is passed through the fractionating column where gases are separated at different heights depending upon their boiling points. And nitrogen has the lowest boiling point, that is minus 196 degrees Celsius. So it is separated first, then argon at minus 186 degrees Celsius and then oxygen at minus 183 degree Celsius. Now like this each gas is collected and it is stored under pressure. A precise flow chart is this. The air is compressed and cooled by increasing pressure and decreasing the temperature. The air gets liquefied and it is again warmed and passed through fractionating column. Gases get separated at different heights like oxygen minus 183 degrees Celsius, argon minus 186 and nitrogen minus 196 degree Celsius. By this the different components are separated. Rest we will continue in the next video. Thank you.